of the earthquake as 3. So thereby it means that in comparison to 2, it is 10 times stronger. In comparison to 1, it is 100 times stronger. Everyone getting it or not? Are you guys able to understand this thing or not?
Tell again
Yes, sir.
beyond what, how much stronger it is.
Yes. Will you
Can you
please repeat that again?
be beyond or below how much stronger or weak?
Beyond.
Or
I'm not getting your
or
question.
below. Like, for suppose
Like,
in the pH level below 7 is acidic, right? And then above 7 is basic. So
yes.
and then in this in Richter scale, if it's below, then it's stronger, right? So, and if it's below, and it's weaker.
Exactly.
Which
Like
is
if you
basically like the pH scale, but not exactly the pH scale.
okay, first let me complete the whole explanation. Okay, now in the explanation, many of your doubts will be covered. Okay, see, this pH, it can be abbreviated as follows. You can understand it as power of hydrogen. All right. Okay. Normally, all the acids that you see, HCl, H2SO4, yeah, HNO3, all of them have got one thing in common, that is hydrogen ion. Okay, now hydrogen ion is always common in both of them. H plus is common. So pH can be seen as an abbreviation as power of hydrogen. Getting it now? Or you can understand it in this manner. Basically, in pH, you are studying about concentration of hydrogen, meaning that how much of concentration of H plus in short I'm writing. So how much of hydrogen is there in the acid, right? If the amount of hydrogen concentration is more, so it will be closer to 0. So as you move from pH 7 to 0, the acidic property increases. Getting it or not? Acidic nature increases. Getting it, Vaika, Sundus and Chakrika? Yes.
Yes.
And as you move from 0 towards 14, so thereby the pH, the concentration of hydrogen is decreasing. Getting it now?
Okay.
So we can say that it is plus H plus. I mean that concentration of hydrogen is increasing this side, while this side you can write it as minus H plus. Okay, no?
Okay, sir.
So that is the thing about it. Okay. Now, like just like I did told you about it, Richter scale, we see that it is not a linear scale, because at every level the earthquake is getting stronger 10 times. So in higher classes now, right now you won't be able to understand this concept, because so many basic things you have to understand it first. But let me tell you, pH, the formula of pH is minus log H plus. H plus. That is the formula to calculate pH. But that is again not related to your syllabus right now. Okay, now. So all I am saying here is that it's not like if you were to have a pH of 7 or pH of 6, it does not mean that there's a difference of one hydrogen between the two. Getting it what I'm trying to say? It will again be in multiples. Vaiga, you are able to get understand it? Sandus, Chakrika,
So,
Yes, sir.
getting it now? So in terms of multiples, it will be differing from each other. Okay. Somewhere, sometimes you see instead of power of hydrogen, it is written as potential of hydrogen also. All right now. Okay, by the way, when I say 25 degrees Celsius, I think I might have taught this thing also, how to convert from Celsius to Fahrenheit or Fahrenheit to Celsius. How do we convert the scale from Celsius to Fahrenheit? Anyone remembers?
sir, you use 3 and 15.
Repeat that again.
Sir, I think we used the 3 and like 15.
Anyone else? Since this thing came right here, look over here. In order to convert from Celsius to Fahrenheit, the formula required is 9 upon 5 into degree Celsius plus 32. Okay, now that is the formula required if you are required to convert a given temperature from Celsius to Fahrenheit. For example, here, as I said, at 25 degrees Celsius, it is seen that the pH of water is 7. So if I were to find that in Fahrenheit, so that will be 9 upon 5 in degree Celsius, that is 25 degree plus 32. So that is 5
Sir,
times 5,
sir,
25
is it
plus 32.
9 upon 5?
No, no, no. That is 9 upon 5, and that is what I've written here. 9 upon
Sir,
5.
below you wrote 9.5 again. Wait,
That's
5
what we
upon.
required to here, required to write over here now. Like here, I have just solved the given question. It's 9 upon 5 multiplied the temperature in degrees Celsius. The temperature in degrees Celsius is 25. So I have simply put that
That
here.
is from Celsius to Fahrenheit, right?
Huh, in order to convert from Celsius to Fahrenheit. So
Okay,
remember
sir.
the formula. To convert from Celsius to Fahrenheit, the formula you have to use is 9 upon 5 times temperature in degrees Celsius plus 32. Getting it, Vaiga?
Yes, sir.
Now, what if you are required to convert from Fahrenheit to Celsius? Simply reverse 9 upon 5 to 5 upon 9. Okay, now? And then
Okay, sir.
multiply it with Fahrenheit minus 32. Here you have added it, here you will be subtracting it. Okay, now? So let's convert back 77 degree Fahrenheit to degree Celsius. So that will be 5 upon 9 into 77 minus 32. So that is 5 upon 9 times 45. So that gives you 25. All right, now? Anyway, so do remember this thing as well. Right? Okay.
Yes, sir.
Now, one another interesting thing you need to know here, that when I give you examples of bases, for example, give some example of bases. I'm writing these things. If anyone wants to note these things down, please do note it, or either take the screenshot. Yes, done. Yeah. Shall I raise it?
Yes, sir.
Yes, sir.
Okay. Now look what happens now. When you look at base, for example, sodium hydroxide, and it is having Na plus and OH minus. These are the ions in it. Ions are what? You will ask, what are ions? So ions are basically atoms with charge. Okay, now charged atoms are basically called as ions. So here you get to see you are having OH minus ion. Take some other example of base. Give one more example of base.
Baking soda.
Which one? Huh. Baking soda, let's say NaHCO3. Okay, now. So look at this one also. This one also will be having OH minus ion in it. Take one more example. Let's take calcium hydroxide also. CaOH whole 2. So this also is having OH minus ions in it. So what we find, that OH minus ion is common in almost every base.
So
Getting
what
it, guys?
about
What about
MgOH2, magnesium
Mg?
hydroxide?
Yes, we can take that example also. Milk of magnesia, that is also having OH minus ion. Okay, now Vaiga. So all the bases have OH minus ion as common. Okay,
Okay, sir.
and we call this ion as hydroxide. Hydroxide. hydro for hydrogen, oxide for oxygen in it. Okay. Now hope it is clear to everyone. So in bases, OH minus ion is common. So thereby what happens now? I can also say that if I were to move from 0 to 14, so thereby the concentration of hydroxide ion will be increasing. Can I say that?
Yes, sir.
Everyone getting it? If I were to move from 0 towards 14, as you know that as you move towards 14, so thereby basic character increases and
Okay.
acidic character decreases.
Okay, sir.
Right, Sandus? Why can Chakrika?
Yes.
So let me now keep it more simple. It's too much of crowded in it here. See, so you have this pH scale 0, 14, and then here you have 7. As I move towards this side, so thereby OH minus, that is the hydroxide ion, is increasing. This is the sign of increasing. Also thereby basic property is increasing. All right. Further, as we move from 14 towards 0, thereby H plus ion is increasing. So thereby acidic character is increasing. So hope that is sufficient to clear the doubts. If you guys have any question in it, please do let me know.
No,
Hmm.
sir.
Is that clear to everyone?
Yes, sir.
Okay then. Now look at some of the common things which we have at our home. Right? For example, like the bleach. So bleach is having a pH of 13. Bleaching powder basically. Ammonia is having a pH of somewhere around 12. So we see that these are strong bases, right? 14. Strongest base, as you said, Chakrika, that is sodium hydroxide. Okay, no? What are some examples of weak bases? We have example of, like, take example of baking soda, that is having a pH of 8. Baking soda. You can take example of shampoo also, shampoo. Okay, no? Handmade shampoo. Sorry, not shampoo, I mean soap, because shampoo is actually acidic in nature.
Yes,
Okay,
sir.
no? Soap. So these are some of the weak bases, and these are the some examples of strong bases. Which one?
Ammonia.
Ammonia, which we have written over here. Okay, Nasundus. Then you have
So
some
calcium hydroxide.
calcium hydroxide also. It will be having somewhere around 10 or 11. Yeah.
Okay, sir.
So we have so many examples. Now, talking about some examples of acids which are stronger. For example, take the example of acid inside our stomach. That is the gastric acids, HCl basically. So that is having a pH of somewhere around 1. Okay, no?
Sir,
In the
nitric
stomach.
acid.
Which one?
Nitric acid.
Nitric acid is also very strong, very good. So in this we can count.
So sulfuric acid.
Sulfuric acid also we can count that.
Hydrochloric acid.
This one I have written over here.
Oh, yeah.
Sulfuric acid. Right. So in fact, what is common in these now, like sulfuric acid or the nitric acid? Most common we see that, like especially the sulfuric acid is made in laboratory. Like nitric acid is found in acid rain also. Stomach, the
So
acid inside the stomach.
nitric acid is basically uh,
Hmm.
an organic acid, but also a
Hmm.
synthetic
Mm,
acid.
Synthetic acid also, because it is usually made in the lab also, right?
So,
And then all the citric acids, for example, especially like found in tomato right now. So it will be having
Sir,
a
is it
pH.
citric or citric?
You can pronounce it as citric, I think. Citric is a better way to pronounce it. Okay,
Okay,
now.
sir.
So you have examples of citric acid also. Citric acid, in fact, most of the citric acid has a pH of 3, right? Then the acid found in tomato, so
So
that is having a
isn't it malic
pH of
acid?
somewhere around 5. Yes, malic acid. Huh?
Sir,
Malic acid is
the
found in it.
oh,
Uh, were you saying something else?
no, sir. I was just asking if malic acid is present in tomato.
Exactly, it is present. Malic acid is there. In fact, some amount of oxalic acid is also there. Right now. Okay, what about milk? What do you guys think? Milk is also little bit acidic in nature.
So,
Okay,
but
no?
if it's sour milk, then it is acidic in nature, right?
Then it is acidic in nature. But usually you get to see now in many cases you see that it is somewhere between 7 and 7.5. Somewhere between not 7.5. I mean 6 and 6.5. Getting it? So it will be falling somewhere here. Okay, no. The
So
coffee
you
that
mean
you
like
drink, that is
six
also acidic in
and a
nature, by
half?
the way. Uh, yes,
Because you marked it
Chikrika.
at 6.5.
Because we can.
No, because you marked it at 6.5.
It can be in decimals also. pH can be taken in decimal also. Okay, now.
So,
In fact, the black coffee that is also acidic in nature. Okay, and that is somewhere again somewhere around 6. Okay, now black coffee. Right. So these are some of the common acids and bases and the given pH of these substances. Right. Okay. Do tell me, how do you store acids? Should it be stored in metal containers, Havaika?
No, sir.
No. Why is it so, Sundas? Why we shouldn't store it in metal containers?
What, sorry?
Why acids should not be stored in metal container? Because it is, yes, Chakrika, because it is corrosive in nature.
Yeah.
It will be reacting with the metal container,
sir,
right?
it can also melt the
If it is a very
melt.
concentrated acid, then it can melt it. Okay. Hmm.
So,
So
but
they,
sir, it's also not good if we even store like organic acids, right?
if we store
Like the weak
organic acids, huh, it is also not good in that case also, because corrosion will happen. Although the rate of corrosion will be very slow, but still corrosion will take place, right? So thereby it is not suitable to put any type of acids, whether it be organic or whether it be synthetic acids, right? In fact, we place all the acids, whether it be organic or whether it be synthetic. It is better to keep them in glass, because glass does not react with acids at all. Okay, no, it does not react with acids. Normally, you might have seen in acids are kept in plastic bottles also, but those are dilute acids. Okay, no, dilute acids are there. So hope it is clear. So neutralization, which we discussed moments ago, like where do we get to see neutralization in our daily life? Where neutralization is happening? Give some daily life examples of neutralization
so
reaction
like
taking place.
reaction or like the
Sir, in
just
digestion.
Viger, that is correct. Yeah, Chakrika.
so like the reaction, or can you just name what we use also, like
Like you can just name some of the situation where you get to see that neutralization reaction is taking place there. Like the one that just Viger answered, like indigestion. We take help of antacids. When too much of
uh,
acid is produced in the stomach, so thereby um, antacid being basic in nature will neutralize its effect.
Yes, sir.
Sir, then ants sting also counts, right? We
Exactly.
apply baking soda solution, or like there's
Oh,
another solution,
Sir,
but I don't
bee
remember the
sting.
name.
yes, Vaika, will you please say that again?
Yeah, bee sting.
Bee sting is also there. By the way, I think apart from baking soda, we can use calamine solution also.
Oh yes, sir, it's calamine solution.
Calamine solution, which is actually zinc carbonate. Okay, no? So let me write this thing over here that in ant testing, you can be using calamine solution also, which is nothing but zinc
Zinc
carbonate.
carb. So
Okay,
also soil treatment. Before you also mentioned it,
which one?
we use soil treatment, sir. If it's
Mhm.
too acidic, we add quicklime, which is calcium oxide, to
Very good.
neutralize it. And if
Mhm.
it's too basic, then we add slaked lime.
Slate lime.
No,
Hmm.
yes, sir, slaked lime.
See. In fact, in
No, sir, wait.
like when it is acidic now, we use both of them. Okay,
Yes, sir.
basically,
But like, if
it's
it's too basic, then we use organic matter, like
Mhm.
decaying
Exactly,
organic matter.
exactly. So see, if the soil is too acidic in nature, so thereby we need to add some bases to it, right? So in order to reduce the pH, reduce the acidity in the soil, what we can do, we can add quick lime to it. Now, sometimes students get confused about quick
Hmm.
lime and slake lime.
So slaked lime is nothing but when we add water to quicklime, it becomes slaked lime, right?
Exactly, exactly. So quick lime is basically calcium oxide. Quick lime is what, Vaika? That is calcium oxide. So see,
Okay, sir.
so you will be having quick lime in the form of powder, or it can be a small rock-like substances, rock-like particles. It is available in the market. We can get it from there. So if the pH of soil is acidic in nature, so what you can do, you can take calcium oxide, that is CaO, add some water in it. So thereby you will be having calcium hydroxide, CaOH, that is calcium hydroxide. And calcium hydroxide is also known as slaked lime.
Lime.
Okay, now
Yes, sir.
slaked lime. So that can be added in the soil. In fact, in villages, people would be painting their house using this quick lime. Okay, now in villages, since this quick lime is actually white in color, this is white in color right now. And also when it is added in water, no, it releases huge amount of heat. Huge amount of heat is released. So thereby it is an exothermic reaction. A reaction
So, but
where
like, why
Mhm.
would they use it to paint? Because, as you said, it releases heat, right? And isn't that like a minus point?
see see what happens now. For a few hours, calcium oxide is dissolved in water. Okay, so at the starting of the reaction, so much amount of heat will be released. It will be an exothermic reaction. But after a few hours, the whole liquid cools down. So thereby then it is ready to be used in order to paint the walls, paint the house. Getting it now?
Okay, sir.
Yes. Okay, now here's the interesting thing. See what happens now. What happens? Calcium oxide, that is quick lime, reacts with water, thereby releasing huge amount of heat. This sign here is the sign of heat. This triangle represents heat. So that will be forming calcium hydroxide. That is the slate lime, quick lime, and water. Now it is painted on the walls. So this is used to paint on the walls. Now what happens? Okay, when it is painted on the walls, now what happens? The calcium hydroxide calcium hydroxide, just 1 minute, will be reacting with the carbon dioxide in the air. It will be reacting with carbon dioxide present in the air. So now once it has been painted on the walls, what happens? Calcium hydroxide reacts with water and it forms calcium carbonate. It forms what? Calcium carbonate, which is hard. So when it is painted, you can see like after few hours or after a day, it solidifies, it hardens. Getting it now? Like at the moment when it is painted on the walls, if you were to touch it, so it will come off. It will start coming off. But after a day or after a day or two, you see that it becomes hard. Why is it so? Because that paint, that is calcium hydroxide, has reacted with carbon dioxide in the air to become hard solid. Is everyone getting this thing or getting confused in this?
No, sir.
No,
Okay, no?
sir.
So that is how it happens. Okay, so here basically we have revised the whole chapter. So we have already did questions from NCERT. So I won't be we won't be redoing those questions. All right. So you guys tell me if you
Okay,
guys
sir.
have any other doubts in the chapter, please do let me know. Or else I'll be asking questions then. No questions.
Sir, no doubt.
Okay.
So can I like go through just once? Can I go
Mhm.
through?
Sure, sure. So in the chapter, basically, we did discussed about acids and bases. Acids are sour in nature, right? Acids are sour in nature, and acids will be converting which paper to which color? Blue litmus
Sir,
paper to
acids turn blue, litmus to red,
blue litmus to red. And in basic solution, what happens? Bases will be turning red litmus paper to blue,
blue.
right? Bases will be having a bitter taste. They are soapy in touch, right? Apart from that, we know that acids are having they when see they are having H plus ions in them.
Hydrogen.
Good. While bases have which ion?
Sir, I
OH
have two
minus.
doubts.
Yeah. Chikrika.
Uh, so actually, this is from my textbook. So is it alright if I ask?
Sure. Take your book.
Yes, sir.
Okay, by the way, there's one more thing. Like when you look at the pH scale, na guys, at 7, what happens now? When the pH reading is 7, so thereby
Neutralizes.
concentration of yes,
It like neutralizes.
huh, the concentration of hydrogen ions and hydroxide ion is equal at 7. Okay, no. So that is another important thing we can learn here. All right, now. Okay. So these things we studied in the chapter. Vaiga, you will also get to revise since you missed the first class in this. Right? We have so many
Yes,
examples of acidic substances at home, like orange juice. All those fruits that are sour in taste consist of
yes,
citric
sir.
acid in it. In vinegar, which acid is found? Sundus, will you remember?
So which one?
In vinegar, silica. Which acid is found
Sir,
in vinegar?
sir, acetic acid.
Acetic acid. Very good. Okay, now.
Uh,
Yeah, so Chakrika.
so the doubt is that the salt which will give an acidic solution on dissolving in water is semicolon sodium sulfate, ammonium sulfate, sodium carbonate, and sodium chloride.
Sodium sulfate, then
And then sodium carbonate,
sodium carbonate,
and then ammonium sulfate,
ammonium sulfate, okay,
and then sodium chloride.
sodium chloride, okay.
And then the question is the salt which will give an acidic solution on dissolving in water is.
The salt which will give an acidic solution
Yes, sir.
on dissolving it water.
On dissolving in water, yes, sir.
Salt which will give an acidic solution, okay, on dissolving in water. Out of these, okay, see. So basically what happens, sodium sulfate, sodium carbonate, and ammonium sulfate and sodium chloride. Sodium sulfate, that is Na2SO4. Sodium carbonate, that is Na2CO3. Ammonium sulfate, NHSO2. Okay. So these are the falling salts over here and NaCl. The question is that which one will give an acidic solution when mixed in water? That is the question, right? Hello?
Yes, sir.
Yeah, Chakrika, you there or not?
Yes, sir. Yes, sir. That's the question. Yes, sir.
That's the question. Sodium carbonate, metal sulfate. The question is which one will be giving an acidic solution when mixed
On
with water,
dissolving water.
on
Yes, sir.
dissolving with water. Okay. Sodium carbonate can be the answer here, but I'm not entirely sure about it. I will have to look into it. Okay, na Chakrika. I will have to look into it. I'm
Okay,
not
sir.
entirely sure, but I
Okay,
think
sir.
sodium carbonate would be the answer here. Okay, now.
Okay, sir.
Are there any
There's
other
also another
doubts?
one.
Huh.
Which one of the following salts will give a basic solution on dissolving water? Sodium
Okay.
carbonate, sodium chloride. So basically the same options.
Same options are there.
Yes, sir.
Okay. And these are also salt. And the question is which one will be giving a basic solution
Yes, sir. On dissolving water.
on dissolving with water. Okay, okay. For this, I think you need to know, in order to understand this, I think you need to learn about amphoteric oxides. Have you learned about amphoteric oxides?
Oh no, sir.
Not yet. Okay, okay. Anyways, okay. Do one thing, give provide the solutions questions to me. I will look into it. Okay, now. Okay. Has anyone got any other questions?
No, sir.
Okay. One important thing I did told you moments ago that at pH 7, the concentration of hydrogen ion and hydroxide ions are equal to each other. Okay, no? So that is another factor, fact which you should note down, right? And then
Can
we
you
did
repeat the
talk
fact?
about the fact is that at pH 7, the concentration of hydrogen ion and hydroxide ions are equal to each other. Getting it now? Okay. We had so many common examples of acids and bases at home. For example, you have vinegar, all the citric fruits. Okay. You have curd. In curd, which acid is found? In curd, which acid is found?
Lactic acid.
Lactic acid is found. Okay. The safety measures, which we also discussed. What are the safety measures? In order to dilute a concentrated acid, we should always be adding what? Acid into water or water into acid? Acid into acid into water, drop by drop, and keep it stirring. We have so many common bases at home, like sodium bicarbonate, that is the baking soda, ammonium hydroxide. So these are some of it. By the way, ammonium hydroxide is used as a window cleaner also, right? Okay. What do we call those bases which are soluble in water?
Alkaline.
Alkaline,
Alkaline.
right? And we know the fact is that all alkaline are bases, but not all the bases are alkaline, right?
Yes, sir.
Then we did talk about different type of indicators as well, right now. The different type of indicators which we discussed, namely we did talked about litmus paper, and then turmeric, then China rose petal was there, phenolphthalein is there, right? And then some olfactory indicators are also there. Neutralization reaction, where basically an acid and a base reacts with each other, and thereby the effect of both the chemical substances are neutralized. Hence, it gives you salt and then water. The common example is that of NaOH and HCl, that gives you NaCl plus H2. So that is one of the common example of neutralization reaction. So these were the general things in the chapter. Neutralization reaction in daily life, which we also discussed. Okay. Are there any other questions, or if there's any other question, please do let me know. So do tell me a few questions then. Do answer some questions. Yeah, Chakrika.
No, I said I didn't have any.
Okay. So do tell me, phenolphthalein, which is a synthetic indicator, and we know that its color in acidic and basic solutions will be what? Phenolphthalein, which you know.
What's it?
Phenolphthalein.
So it'll be
But
colorless in acidic solution, and it'll be pink in basic solution.
pink in basic solution. Very good. So in acidic solution and in basic solution, in acidic it remains colorless, while in basic it changes to pink color, right? Okay. When the soil is too basic in nature, so thereby plants will not be growing well in it. So to improve the quality of the soil, what should be added in it? Should we add organic matter in it? Yeah.
So can you repeat the question?
My question is
I
that
didn't.
I'm repeating the question. When the soil is too basic in nature, so thereby it is not good for the plant to grow in it. In order to improve the quality of the soil, what should be added in it? Should we
So we
add
have to add
organic matter?
organic matter.
What about quicklime, or what about slaked lime, or what
So
about
that's when it's too
calamine
acidic.
solution?
No, it's organic matter.
The question is that the question uh, is were you guys answering organic matter?
Yes, sir.
Everything organic matter.
That is correct then. When the soil is very basic, then what if the soil were to be very acidic in nature?
So if it's acidic means we will add like calcium oxide,
That is actually quicklime.
quicklime, or slaked lime, calcium hydroxide.
When water is added in it, and then by it converts into slaked lime. Okay. Okay. By the way, neutralization reaction that happens. Do tell me that is it a reversible change? Is it a reversible reaction? Can it be reversed?
So what's that?
No,
Neutralization reaction, is that a reversible reaction?
No, sir.
No.
Yeah, no.
No, it is a irreversible reaction, and in fact, it is a chemical change. So thereby, it is an irreversible reaction right now. Okay. Now, do tell me, I am giving you some examples like option A consists of grapes. Take example of lime water. Take example of vinegar and then soap. Third option, take curd and milk of magnesia. The last option is curd and vinegar. Now the question is that out of the given set of different substances, do tell me which of the following sets of substances here contains acids. Both of the
So what
substances
is the
have
third one?
A.
third one is curd and milk of magnesia. First one is grapes and lime water, vinegar and soap, curd and vinegar. All the
So
option. My
curd and
question is that
vinegar.
curd and vinegar. Very good, because it consists of lactic acid, and this
And
consists of
vinegar consists of acetic acid.
acetic acid. While grapes is having citric acid, but then lime water is basic in nature, CaO plus water. So thereby it is slaked lime actually. Lime water, we are referring to slaked lime. Then milk of magnesia is also basic in nature, which is used as an antacid, MgOH whole 2, that is magnesium hydroxide. So that is the thing. Now, like, you have taken a colorless solution. You have taken a colorless solution. I mean to say, you have taken a solution right now, and thereby you added phenolphthalein in it. You have added few drops of phenolphthalein in the solution, and the solution remains colorless. What do you understand from this? What is the nature of this solution?
Acidic in nature.
So
Acid.
like alkali solution is added to it.
No, no, we have added phenolphthalein. We have added phenolphthalein, which is an indicator. And when we added few drops of phenolphthalein in it, the color is colorless. It is a colorless. The color is not changing. So as Sundhu said, it is a acidic substance. Okay, no?
Oh, okay, sir.
So that was the question. Okay. Do tell me that say that HCl you are adding, let's say, sodium hydroxide in it. Okay. So thereby you would be getting what?
Salt and water.
Salt and water. Can you name the salt and the water which you will be getting?
NaCl plus H2.
NaCl and H2.
Mm.
Good. Okay. Let's take a different example. What if you were to have another acid? For example, let's say you have HNO3. Okay, now. And then let's say you have another base, CaOH whole to calcium hydroxide. So then what you will be getting? HNO3 plus CaOH whole 2. What you will be getting in this case? Yes, anyone? HNO3 is an acid.
So yeah, it's nitric acid, right?
It is nitric acid. Calcium hydroxide is a base. So what will be happening here? Do tell me. Take your time and do tell me.
So basically, we have to do what? Like, we have to find the answer.
Basically, when HCl and NaOH was reacting, so thereby you are getting NaCl and H2O. So when HNO3 reacts, so they with the calcium hydroxide, so thereby what you will be getting?
Or is it Na2CO3?
No, let me tell you. It is
So
calcium nitrate, CaNO3 whole 2 plus H2. Okay, no? Okay, so if you want, you can remember one more example of neutralization reaction. Okay, no? Okay, so hope it is clear. If there's any other doubt, please do let me know. Okay, now.
No, sir.
And Chakrika,
No,
I
sir.
will have to let me look into your doubt. I'm not entirely sure about that.
Okay, sir.
Okay,
I'll
no?
send a pic of it.
Okay. Okay, so that's it for today. We'll be meeting in next class then. Also, do tell me which chapter we should be revising in the upcoming class.